Welcome to the second video talking about silicate minerals and mineral groups. I'm Aida Awad from Broward College. In this video, we'll talk about identifying elements that are commonly found in the minerals in Earth's crust. We'll compare and contrast the major mineral groups, and we'll talk about basic silicate mineral structures and their importance. First of all, we know that the Earth's crust is made of only 8 elements primarily, and that 0.8% of the crust is made up of all the other elements. So you can see in this pie chart here that the 2 primary elements found in all of the rocks in Earth's crust are oxygen and silicon, and together they make up over 70%. The others are aluminum, iron, calcium, sodium, potassium, and magnesium. So together, those 8 elements make up the great majority of the rock-forming minerals in Earth's crust. Speaking of rock-forming minerals in Earth's crust, let's turn to the silicates. So we just noted that silicon and oxygen make up the majority of Earth's crust's minerals, and those make up the silicates. Now, silicate structures form around the basic silicon-oxygen tetrahedron, which is SiO4. And you'll notice that SiO4 carries a -4 charge. So it's very happy to have metals bonding with it to make that charge imbalance neutral. There are several different types of silicate structures that we see in igneous rocks within Earth's crust. So over on the left side of this diagram, you start with the isolated silicon-oxygen tetrahedron, which typically bonds with magnesium or iron to form minerals such as olivine. Moving towards the right, 2 tetrahedra share an oxygen and form a paired tetrahedron, or a bow tie structure. 6 tetrahedra can share oxygens to form a ring structure. Another common arrangement of silicon-oxygen tetrahedra is a long chain structure, and the chain silicates are those such as the pyroxenes, commonly found in igneous rocks. Multiple chains can join together to form a double chain, and that's the amphibole group, which contains hornblende, another common mineral in igneous rocks. Again, multiple chains can form large sheet structures, and that's what we see in the micas, biotite and muscovite in igneous rocks. Those are the flaky minerals with just one direction of cleavage that peel off like layers. And finally, sheets can stack atop one of another and form framework structures, and that's what we see in the feldspars and in quartz. So those are the different silicate structures that we find in igneous rocks. Now, most minerals that are found in the crust are silicate minerals, and they fall into 2 main categories. And those are the light or felsic silicate minerals, or the dark-colored or mafic silicate minerals. Mafic silicate minerals have iron and magnesium in them in greater percentages than do the felsic minerals. They also exhibit that dark color because of the presence of the iron and magnesium. The felsic minerals tend to be lighter in color and are minerals such as feldspars and quartz. Non-silicate minerals are very important in terms of industry. And here you see a couple of maps. The map in the top left corner lists locations where aggregates are resourced. So those areas in green indicate areas in the United States where granite is extracted. The areas in fuchsia indicate areas where limestone is extracted. And then we see in yellow the sand and gravel deposits. Down in the bottom right, you see some active surface mining operations from 2014 for stone, sand, and gravel for the industrial sector. So these are minerals and resources that are used in industrial and infrastructure and building. They're typically non-silicates, but as you can tell, they're very important economically. So in the next chapter, we're going to be talking more about rocks, but just to give you a little bit of a preview, we can talk about compare and contrast with minerals and rocks. Over on the left side, you see that minerals really have an individual mineral has a single chemical composition. It's inorganic and has that distinct internal arrangement of atoms. Minerals and rocks commonly are solid, they're naturally occurring, and some rocks are single mineral rocks, such as dunite, which is made up only of olivine. Rocks, on the other hand, are aggregates typically of multiple minerals. They may include other non-mineral matter, such as glasses, like the rock obsidian. They may also include organics, like coal. And they tend to be classified by how they were formed into categories of igneous, sedimentary, and metamorphic rocks. So check back on your learning targets. I hope you enjoyed this video. See you on the next video. Bye-bye.